Hello, my dear students. Today I am going to discuss another important phenomena of nuclear chemistry, that is nuclear fusion. This is very important phenomena which is taking place in the nature. So without this process, no world, no universe exists. So why? Because let us observe this picture. So this is our solar system, including 8 planets and a star sun. So the distance between the sun and the earth atmosphere is 152 million kilometer. 152 million kilometer. So our earth is the third planet. It is here. It's the third one from the sun. The first is Mercury, second is Venus, and the next is our earth. So more than 50% of our earth surface is covered by sunlight. So due to this sunlight, the photochemical reaction takes place, and because of this photosynthesis process, we are all getting food. That means on the earth surface, so many species, plants are exist because of this solar radiation, sun rays. And these sun rays are produced from the sun. So why they are producing? They are producing because a special phenomena, that is a nuclear fusion reaction which is taking place in the sun. That's why they are continuously emits radiation. So one nuclear phenomena, nuclear reaction, that is nuclear fusion reaction, which is continuously taken place in the sun. So because of this phenomena, it emits radiation, and because of then we are utilizing our radiation for survival. Then fusion. Fusion means, before going to understand fusion, in sun 73 percentage of hydrogen is present, and nearly 24% of helium by mass is present in sun. So totally the abundant element in the universe is hydrogen, because sun contains 73% of hydrogen by mass. So these hydrogen undergo fusion reaction combine. So hydrogen means it's a lighter nuclei. It has only one proton and one electron in it. So it doesn't have neutron, and it has isotopes. So it is deuterium, tritium, and so these hydrogen nuclei, are the isotopes of the light elements like hydrogen and hydrogen isotopes. So combine, the lighter nuclei combine to form heavier nuclei along with emission of lots of energy. So this is called as nuclear fusion reaction. So before going to understand the mechanism of the nuclear reaction, you must know one thing, that when during fusion reaction, the two lighter nuclei, that is the two lighter hydrogen atom, comes closer to each other. But the one important thing here is, when the nuclei come closer to each other, there is a lots of repulsive force because of the positively charged proton which is present in the nucleus. So this nucleus is responsible for repulsive force. So in order to eliminate this repulsive force, because in order to combine, they must come closer, but due to the repulsive force, what happens? They can't meet each other. But if more energy is applied, that is more thermal energy is applied to this process, at that moment the fusion of nuclei takes place and it forms larger nuclei. So here in sun, the four hydrogen atoms, the four lighter hydrogen nuclei, undergo fusion to form helium, along with it emits two electrons. Now let us see the energy which is released in each fusion reaction, because we know that it emits energy. The temperature is around 5700 Kelvin, and it has to travel some million kilometer. That means it must it must emit sufficient of amount of energy in order to reach the various planets which is present in the solar system. So the energy can be calculated with the help of mass defect. So you know the mass of helium is 4.0026 AMU. So you know the meaning of mass defect and binding energy. And the mass of helium has 2 proton and 2 neutron. Its mass is, so the mass of proton is 1.007825 into 2. So plus there are 2 neutron. So of one mass of 1 neutron is 1.008665. Then if you simplify, you are going to get 4.03298. So this is a individual masses of protons and neutron. Then we know the formula of mass defect. The mass defect is equal to ZMP. So Z is the number of protons, MP is the mass of proton, A minus Z is the number of neutron. So Mn is the mass of neutron minus M here. M is the mass of helium. If you substitute the value, of these M and the individual masses of proton in this equation, so we are going to get the mass defect 0.03038 AMU. So now we have got mass defect. If you substitute the value of mass defect into the binding energy equation, that is binding energy equal to mass defect into 931 mega electron volt. If you substitute here, so we are going to get 28.299 mega electron volts of energy is obtained in each fusion reaction. So then this is the energy for one reaction, that is this is the energy for, then this is the energy for 4 hydrogens. Then for 1 mole of hydrogen, so for 1 mole of hydrogen you have to multiply this with, so this with Avogadro number, so you will get 170.445 in 10 to the power of 23. So mega electron volts of energy is obtained. So we know that 1 mega electron volt is equal to 1.602 in 10 to the power of minus 16 kilojoule. So if we convert mega electron volt into joules, so as I said, we can express energy in 2 SI unit either in electron volt or in kilojoule. So first we have calculated in terms of mega electron volt. So then, so this mega electron volt can be converted using this relation, that is 1 mega electron volt is equal to 1.602 into 10 to the power of minus 16 kilojoule. If you substitute this value, so you are going to get 27.3 into 10 to the power of 8 kilojoules of energy is produced. So after the fusion of 1 mole of hydrogen. So this is the energy. So next, thermonuclear reaction. So this nuclear fusion reaction is called as thermonuclear reaction. Why it is called as thermonuclear reaction? Why? Because as I said, when two lighter nuclei comes nearer, at that moment lots of repulsion takes place. So more energy is needed, sufficient, required for fusion reaction to eliminate this repulsion reaction. So that's why, so once the nuclear fusion is initiated, it's going to emit lots of thermal energy. So this thermal energy is sufficient to maintain the chain reaction, the temperature. So this fusion reaction, and that's why, and after also it's going to emit lots of thermal energy. So that's why this is called as thermonuclear reaction. That is, here thermal energy is a driving force in order to eliminate the repulsion which is exist between the two combining lighter nuclei, lighter hydrogen. So for this, so lots of thermal energy is required. That's why this is called as, this is not a nuclear reaction, but it is a thermonuclear reaction. So my dear students, while discussing nuclear fusion, so you have to remember nuclear fission reaction, because there is a lots of difference between fission and fusion reactions. So this is the reaction. So when energy is released from the sun, so it's due to this reaction. This reaction takes place in 3 steps. So in the first, what happened? So the hydrogen combine with another hydrogen. So it gives deuterium. It's isotope and it emits one electron and energy. So again this deuterium is combined with another hydrogen, it forms tritium. It forms tritium, and this tritium again combined with another hydrogen, it gives helium nuclei along with electron and energy. So totally four hydrogen undergo fusion to form helium, and so two electron plus energy. So this reaction is going on. So you may ask the question, so how long this reaction takes place? This reaction takes place up to the completion of hydrogen. Once all the hydrogens are converted into helium, at that moment sun stops to emit radiation. So at that moment it is treated as black body. So at that moment the life of sun ends. Actually, another nearly 4 billion years, still we have 4 billion years to complete all these hydrogen into helium. But once so all the hydrogen is converted, then there is no fusion reaction, then there is no radiation which is emitted from the sun. And the energy released per gram of hydrogen, if you calculate, so just now we calculated for mole, and if you calculate for gram, so the energy is 6.77 into 10 to the power of 8 kilojoules. So in the uranium, so it is around 10 to the power of 7 kilojoules. You compare the energy 7 kilojoules, but it is so 3 times greater than 10 to the power of 8. So 10 to the power of 7, 10 to the power of 8. So more than 10 times greater, 1000 times greater than that of so nuclear fission reactions. Next, distinguish between fission and fusion reaction. There is a lot of differences. So one is in fission, so in fission, the avian nuclei due to instability split into two smaller nuclei. But in case of fusion, the smaller nuclei so combine to form avian nuclei. But in both the process, they are going to emit lots of energy. And the nuclear fission reaction, so it may be it may or may not be a chain reaction. You know that. So we can it is not controlled. If you are not used cadmium rod, it is uncontrolled reaction. Or by using cadmium rod, we can control this reaction. But you cannot control this nuclear fusion reaction. That's why it is always a chain reaction. And this nuclear fission is a spontaneous reaction, and so it is independent from a temperature. Here no temperature is needed, even at any temperature, at any concentration, so fission reaction takes place. But this reaction is temperature dependent. That's why we call this as thermonuclear reaction. I told in the previous slide that there is a repulsive force. So in order to eliminate repulsive force, sufficient amount of thermal energy is needed. That's why it is a temperature dependent. And nuclear fission reaction, it can be controlled, but it can't be controlled. So in case of nuclear fission, tremendous amount of energy is released. But in case of fusion, the amount of energy is released is 7 times greater than that of fission reaction. So in the nuclear fission reaction, the byproducts are harmful. You know that. So in the nuclear fission reaction, so it is fission, it is going to give a byproduct. The byproducts also radioactive. So these are emits harmful gamma radiations. That's why the byproducts are harmful. But in case of nuclear fusion reaction, it's going to produce helium. Helium belongs to 18 group. It is inert in nature. That's why it is not harmful. And the best example for the fission reaction, this principle used in the in the preparation of atomic bomb. But the nuclear fusion reaction, it is used in the reactions on stars. Reaction in all the stars, the nuclear fusion reaction takes place, and in hydrogen bomb they are going to use this principle of nuclear fission. So these are the difference between nuclear fission and fusion. In the next class, I am going to discuss applications of these radioactive elements.